Hi, it's Robin. In a previous video, I looked at various Commodore 64 programs that are in some way incompatible with the Commodore 128. Based on the comments I got, probably the most popular game of those I mentioned was Frantic Freddie, which is a very early C64 game from 1983 that has addictive, if frustrating gameplay, and even more famously, really great music. Perhaps ironically, when Frantic Freddie is run on a Commodore 128, it's totally silent. As explained in that previous video, the reason is that Frantic Freddie uses mirror or alternative addresses to address the SID sound chip. Instead of using the official D400 range of addresses, it uses a D500 mirror offset by 256 bytes from its true location. These alternate addresses are valid on a regular C64, but are not on a Commodore 128, which wasn't even released or even created until a couple years after the game Frantic Freddie was released. So I went ahead and fixed the game so it works properly on the Commodore 128. I think I mentioned I might make a video about that process, but on further thought, I just don't think it would make all that interesting a video. So instead, in this video, I'd like to look at some of the other things in Frantic Freddie that I've been having fun with and that are interesting to me. So I've heard there's a couple bugs in Frantic Freddie, and I'd like to look into those. One of them I've already seen for myself. After every 2 levels in Frantic Freddie, a little 15-second intermission plays, which was probably inspired by Pac-Man's intermissions. The second intermission, titled Freddy's Revenge, has a little glitch character just sitting there on the right edge of the screen. I was happy to ignore it while working on the previous video, but then my patron James Pohl pointed it out. He said, "If you do decide to make a video showing how you fix the game, maybe you could also try to pin down that annoying character glitch on the second intermission screen. What is that little symbol at the end of the Freddy's Revenge line?" And there's mention of another bug on the Wikipedia page as of the making of this video. It says, "The 17th level has a game-breaking bug, as this level mistakenly has all poles removed." That is, those ladders, they're actually telegraph poles, according to the game. This means that Freddy can't reach the platforms above him, making this level impossible to clear. So I want to look into these bugs, but this game is brutally difficult. It's difficult enough to even finish just 4 levels to see that second intermission glitch, never mind to get to level 17, which seems impossible. In the nearly 40 years I've been playing this game, I don't think I've ever gotten past the 8th level. So if we're going to investigate these bugs, we need to figure out how to improve our odds, or, in other words, cheat. So I've got Frantic Freddie here in a D81 that I made for that previous video, no work on C128. And it should be easy enough to find these online for download if you want to follow along. This is the version that's fixed for the Commodore 128, but still works fine on a classic C64, so we'll use it today. Okay, so we'll go through and create a couple cheats for this game that will help us in our quest to see these bugs and possibly fix them. I've got my Easy Flash 3 here with a Super Snapshot ROM installed. And again, you can find these on the internet. You know, I love my Super Snapshot cartridge, but they're very hard to find the originals of now. So you can actually just use an Easy Flash 3, or I also use a Kung Fu Flash from The Future Was 8-Bit, developed by Kim Jorgensen. And either of those cartridges will work fine running the Super Snapshot cartridge or binary file. Additionally, my friend Adrian Gonzalez has made an updated Super Snapshot ROM that's available for download. It has several improvements, and I'll put a link to that in the video description if you want to try that for yourself. That's what I'm using today. So the most classic cheat is infinite lives, making it so you don't get game over no matter how many times you die. So with my Super Snapshot cartridge plugged in, it has a utility that helps with this process. Let's try it. Just start a game, and then press the special or freeze button. And then here at the subsystem menu, press 3 for Game Master and 5 for Infinite Lives. And it asks, how many lives do you have left? Well, in Frantic Freddie, we start with 3. So we'll enter that. And it searches through RAM. And what it's actually doing is looking for any memory address that has a 3 in it and a corresponding decrement instruction, meaning that decrease the number of lives. So it's found 6 possible candidates for this, and it tells us it's going to remember those automatically. Now it tells us to lose a life and then select again. So we'll do that. We'll return 6 and 7 to resume. And I'm going to deliberately run into one of the bad guys here. And then I'll press the special button. And you see at the top it says we have 2 lives. Okay, so again, Game Master and Infinite Lives. Now how many lives do we have left? 2. And it thinks about it for a bit, and it says installed. Press A key to continue. And I've made note of both of those addresses, 03DB and 09A1. That's actually where it found decrements that did have 3 in their destination and then had 2 this next time we ran it. So that's how it knew. Very likely. It's not that this is a perfect process, but it is pretty good. Okay, so I made note of those addresses. Not that you need that just for this basic function, but it might come in handy after. We'll actually look at what it did. You guys like a bit of machine language, right? Go back to the subsystem menu and press M for a shortcut into the machine language monitor. And now we're going to disassemble one of those addresses it gave us, 3DB, and then scroll down a bit. And we see 2 load A with 3 A's in a row. The cartridge, I think correctly, determined that location 3A holds the number of lives, the number of Freddies left. And normally, this would actually be a decrement instruction, and then it would load, and then it would compare it with 0, which strictly speaking isn't necessary. That's automatically done when you do a load. The 0 flag is set. But anyway, we won't complain. The programmers of this were just in their teens when they made this game. I'm super impressed what they managed to do in 1983. But anyway, before, this is with the patch installed. I'll just show you what it did have. It was C6 is the machine code, the opcode for the decrement instruction. So normally it would decrement location 3A, then load it up and compare. But for Infinite Lives, that C6 just becomes an A5. And now you see it just loads it harmlessly, doesn't decrement it, loads it again. Basically, 3A will never get decremented down to 0 because of that little hack or patch that it automatically figured out. Okay, so let's try playing the game a little bit now that we've got that. See, we have 2 little men up at the top, right next to the scores, those little Freddies. And you see now we die, and we still keep having 2 lives. So that's pretty good. I'll try and finish a level. Oh, brutal game sometimes. There we go. Finished a level. Infinite Lives is great, but how about a quicker way to skip levels? So if we just start a new game here, by the way, yeah, I tapped restore and it sends us back to the title screen. Start a game. Might notice that we have 10 pots of gold on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. Okay, and so collecting all 10 is what finishes the level. Okay, so you might find it interesting that we can actually repurpose the Infinite Lives feature to help with other kinds of cheats. So knowing that there's always 10 pots of gold, let's try that. We'll start a game here, and I'm going to freeze. And again, we'll go into the Game Master, Infinite Lives. How many lives do you have left? Well, instead of how many lives, let's tell how many pots of gold we have left. 10. Nothing. Select again and retry. Okay, this sometimes happens. So we'll return and we'll resume. I'll pick up one of them. I'm going to freeze again. We should have 9 pots again now. Game Master, Infinite Lives, 9. Okay, so now it detected 6 potential spots. And let's try and get down to 8. There we go. I picked up one more pot of gold. 3, 5, 8. Okay, and there we go, installed. Press any key to continue. So again, I've made note of those 2 addresses, and we'll look at those in a little bit. But let's just return. Now, this alone isn't solving our problem, because watch what happens. If I pick up all the pots of gold, come on. Okay, now, look, I picked up all the pots of gold, and the level did not clear. Well, that's because instead of infinite lives, what we have? Infinite pots of gold, or like basically you can't pick up all the pots of gold anymore because we've disabled. Normally it would count when we've picked them up. It'll have marked down, you know, like how many are remaining, but that's not getting decremented anymore. So it still thinks we have whatever, 7 or 8 pots of gold, like when we cheated it there. Oh, I'm staying alive for a long time. Okay, so that's not really what we wanted to do, but it gave us those addresses. It's a really easy way of finding the memory location where the number of pots of gold is stored. Okay, so I'm actually going to reset just because we kind of messed things up there. And I'm going to restart Frantic Freddie. Okay, so I'm going to freeze, go into the machine language monitor. You'll notice that there were 2 addresses changed. Frantic Freddie seems to load all of its code into one contiguous block of RAM and then copies bits of code to other areas of memory where it's then run. And this must have had something to do with the development process. Basically, it means that some code is duplicated, but only one is active. One was loaded into RAM, but that was moved to a different location where it was actually meant to run. So through trial and error, I figured out when we're given 2 or 3 duplicate places, I found that if it's higher in memory, then the higher address is correct. And if it's quite low in memory, then the lower address is correct. That's the general rule. So for the pots of gold, we're going to ignore the one that was in the 8,000 range and just look at the F5 3E. So it's telling us that location 4E in 0 page is holding the number of pots of gold. And each time you pick one up, that's decremented. And then it's loaded and checked against 0. And of course, if you're at 0 pots of gold remaining, then you're done the level. So what I wanted to do was find out where are the number of pots of gold initialized. So if we hunt from memory, all the way from 0 up to FFF, that's the whole 64K range of RAM. And we're going to search for A90A. And what this means is load A with the immediate value A hex, which is 10 decimal. And that should be the 10 pots. Okay, so it turns out there's actually lots of instances of loading the value 10 into the accumulator. But then we're going to follow that with storing A, which is the machine code is 8.5 for that, which you can look up in the Commodore 64 Programmer's Reference Guide, or for that matter, if you know you have a couple safe bytes here, you could just type assemble and the machine language you want, and it would show you the hex bytes. 8.5 and then location 4E. So we're going to hunt through memory. Where are we storing into into the correct memory location where we keep track of the number of pots? Okay, so we get 2 addresses. It's almost like we didn't even have to do this one. this upper one is probably the correct one. We see here F3E5. If you look up here, just a few bytes earlier, 4 bytes earlier, there was a load A with 10 decimal. And then here we have a store in the number of pots. Okay, so let's look at F3E1. And there we go. Putting 10 into these two locations. I actually didn't look into what this one is, but I know this is the number of pots of gold. So if we just change the 10, the A hex, which is 10 decimal, to 1, I think we've made it. So there will only be 1 pot of gold to collect. So we're going to exit and resume. And here we'll try playing the game. And sure enough, that was only 1 pot of gold. That was quicker. And there's another one. 2. So actually, after playing this a bit, I found this was good, but actually sometimes the 1 pot of gold was really hard to reach. And you might find it hard to believe right now, but when you get to level 13, 14, 15, and so on, okay, there's the 1 pot of gold. So that's actually kind of hard to get to. Oh, there was an easy break, but okay, here. 1 more we can get here, and we'll have finished 4 levels. Okay, here's that Freddy's Revenge. I think I showed that earlier, but there's that little glitch over at the far right, upper right of the screen. That really shouldn't be there, I think. So anyway, what I thought would be even easier is if we can plot all 10 pots of gold, but only need to collect 1 of them. So let's make that little change here instead. Okay, so fortunately we already know the code that's necessary for this, or the area of code. It's what we were just looking at. Disassemble at F5-3E. And what we're doing right now is decrementing, we're loading it, we're comparing it with 0, and if 0, we're branching ahead to the set carry to clear the level or to finish the level. So if we just reverse that and go assemble F5-4-4 and go branch if not equal to F5-4-8. I'm sure there's other ways of doing this, but I like that this only changes 1 byte. And now this F0 has become a D0. And now we can exit, resume, and let's try playing the game. Now we got all our pots of gold, but we only had to collect 1. And this really makes the game as easy as I can think of to quickly go ahead here. Now, one thing is that when we're going through 16 levels, I thought we were set now, but these intermissions actually get really tedious after a while because they happen every 2 levels, and there's only 2 of them. Oh, there, we finished that level. We didn't even have to move. Oh, it's plotting the gold right under us. But here we are stuck at this intermission again. So, okay, so I'm just going to go back to the title screen and go into the monitor. Okay, you know what? Let's at least fix that second intermission now, and then we'll look at trying to skip the intermissions. Okay, so again, if we use that hunt feature, and the line that's glitched says Freddy's Revenge. So let's search through memory for that. Oh, look, and we actually have 3 instances of it. Just through experience, I believe 1419 is the correct match, and the others are old copies or other uses in the game. Okay, so I'm going to inspect memory, starting at a little earlier, 140D. And here we'll see the text, Freddy's Revenge, and on either side of it are a bunch of 20, and those are just blank spaces. That's a 20 hex or 3232 decimal. The ASCII space is 20 hex or 32 decimal. You'll notice here that this is a 40 character line from 140D, and it's like padded out. It's kind of like a centered line, right? You got spaces before it, then you have the text here, and then you have some more 20s following it. Well, we have 39 characters, and then we have this A2, which is like a graphic character. And that actually looks like code, like an opcode. So I'm going to disassemble. So it's right here, 1435. It's the byte before that. Disassemble 1434. Yeah, and sure enough, that A2 is a load X with 27 hex. And we'll just look through it here. So what we have here is a loop. 27 hex is 39 decimal. So you have an offset of 39, and it's copying characters from 1398. And this is screen memory right now, 4800. And that's saying color memory. So basically we have a string copy or a memory copy routine that's copying 40 bytes from these locations and putting it on the screen. The first line, and here's the second line. Actually, we can look at that. If we look at 1398, see this up here? It's doing the copy from 1398 plus X. So if we look at 1398, well, there's interlude 1. And if we look at the next one, 13BF, right here, that's Freddie's foe. That's the name of the first one. And then if we continue on with the code from up above, right here, 1450, here's another identical copy routine. That's copying from 13E6 and 140D. And 140D is what we were just looking at. If you see the problem here, 27 hex plus 140D adds up to right here to 1434. They should have put an extra 20 here, an extra blank space. They left one blank space out just of that final string of the second intermission, second line. Now, it'd be nice if we could just put a 20 there and fix it, but this is an important byte of code. It's actually the beginning of the copy routine for intermission 1, so we can't do that. Okay, but almost as easy, what if instead of copying just for the second intermission, what if we only copy 26 hex bytes? Just change that to 26. It's going to copy one less byte. It would just copy a space anyway. So it really shouldn't matter unless there's something already in that location that this code was overwriting, was blanking out. But I happen to know, while I was preparing for this, that actually a screen clear routine is called here at 1382 right before. And you can see it wipes out not just the 1000 bytes of the screen, it fills them with 20, the blank space. It actually copies 1024 bytes, so it even overwrites the sprite pointers that are at the end after screen memory. Kind of overkill, but I guess it must reset those each time. So basically we're just changing location 1451 here from 27 to 26 hex, 26 hex. Okay, so let's just give that a try. We'll resume. So we'll just play through again just to level 4. And yeah, we have to we'll sit through this interlude one more time. But assuming that this interlude 2 is fixed, what I'm going to try and do is make it so you can press the fire button to skip these interludes. Okay, there's level 3 done. And let's see if level 4 goes. Here we go, intermission 2. Yay! Freddy's Revenge no longer has that glitchy character over at the far right. That A2 is still in memory, but it's not being copied onto the screen. Good. Okay, so I think we've got our infinite lives. We've fixed intermission 2. Now we want to make a run right to the end of the game with all our cheats. But those intermissions are annoying. And I thought it'd be kind of fun to dig into how to skip those. Okay, so actually what's best is if I start a game again. So sorry to do this one more time, but if we go into one of the intermissions. And while it's running, I'm going to freeze the game. There he goes. Go into the monitor. And if we look at the PC, or if we just type R again, it shows that the PC, the program counter, is at 12 F8. Okay, well, if we disassemble at 12 F6 here, this is where the program counter was. This is basically a busy loop, and all it does is burn CPU cycles. It'll load the accumulator with C8, which is 200 decimal. It'll subtract 1, and if it's not equal to 0, just branch back up here to 12 F8. Well, if you do the math, this subtract takes 2 cycles, machine cycles. The C64 does roughly 1 million cycles per second, 1 megahertz. This is 2 cycles, and a branch, if not equal, if true, will take 3 cycles. A branch takes 2 automatically, and if it's taken, it takes a 3rd cycle. So this is 2 cycles, 3 cycles, 5 machine cycles, times C8 hex 200 decimal. 5 times 200 is 1,000. So this seems like a very deliberate routine that burns 1,000 cycles, and then it decrements Y, and if that's not equal to 0, then it does this whole 1,000 cycles again. So basically, you load Y and JSR to here to 12F6, jump to the subroutine, and it'll burn roughly Y multiples of 1,000 worth of machine cycles. So if you load up Y with 5, this will burn 5,000 cycles. This routine is running a lot during the cutscenes, just because the computer doesn't have anything else to do, just to time out the animation. Otherwise, the animation would just go so fast. This isn't necessarily the best way to do it, but it's how they did it in 1983. Okay, so this is going to be useful to us later. Now, who's calling it? So if we look at the registers again, SP stands for stack pointer F9. Well, 6510, or 6502, 6510, has a 256 byte stack, and it's fixed at memory page 1, or 01 if you prefer. And we're just going to look at memory from 01F0 up to FF, okay? This is the last 16 bytes, or actually the first 16 bytes of the stack. It starts at FF, and stuff gets pushed on, and it works its way down. And actually 256 bytes of stack is lots for machine language programming 6502. I've never come even close to running out of stack space. Stack-based languages like C or whatever, then it is a problem. But it is not a problem for us. Anyway, okay, so stack pointer is point F9. Well, that's actually pointing at the next free spot. So we look at the previous 2 addresses. And why are we doing this? We're trying to figure out what called this delay subroutine up here. Who called it? Well, this is how you can figure it out. You look on the stack, and here, 105A called it. Okay, so if we look at memory, so maybe we can just look at memory starting at 1040. And here is the routine, and we can see we're actually in the middle of the animation. These decrement D1000, that's actually moving Freddy and the monster to the left. It's actually adjusting the sprite X positions. It's doing some other stuff here, and then it's loading Y with 5 and calling our delay routine. So that burns 5,000 cycles, and then it says jump to 1048. So we go back up here and we move our little sprites again. This is actually almost like a script in machine language. It's moving the sprites across the screen, and then it's calling these routines. I believe this one is actually checking to see if you've reached the end of the left edge of the screen. And if it's true, then carry will be set, and we'll branch ahead to 1061 down here, which is the next part of the animation. So the animation is just broke up into these little pieces. Move the sprites, move the sprites. And actually, I found while I was doing this, the cutscenes, cutscene 1 and 2, actually share the same code for the beginning chase scenes. But you see the movements are actually the same if you look at it later. So I thought that was a neat little thing. Doesn't really matter. It's just to give you an idea of what's going on here. So the animation routine's all in this 1000 area. Now, if we just look at the stack again at 1F0, and the stack pointer is pointing here. This is the previous routine. Well, what called that? It's right here at 045D. So let's look at 0440. And here's kind of like the heart. I've worked out what most of this does. So just to go through it here, we're going to load A with location 3B, which is actually the level number. We're going to compare it with level 2. And a little bit weird the way it does this, but that's okay. Branch of carry clear to 0465. We'll scroll down a little bit more, see that, and that's just the return. So basically, if the level is less than 2, then we just return. Then we're going to AND it with 3, which basically gives you 4 possibilities. Now, actually, the level goes from 1 to 2, and after you've completed level 2, this is still set to 2 while the cutscene runs. So AND 3 is going to just kind of mod it, so you have 4 possibilities. You're at level, well, you won't have a level 0, so it'll be 1, 2, 3. The next time around, it'll be level 4, 5, 6, or 7, but actually that'll get reduced down to 0, 1, 2, or 3 again. So essentially you end up with levels numbered 0 through 3, and then it shifts it right to push 1 bit out into the carry, and then you branch of carry set to 0465. So basically, if it's an odd number, if you just finish level 1 or 3 on this mod 4, this rotation of 4 levels, then you also branch ahead to 465 to the return, because odd levels don't have cutscenes. Then we're going to flip the bit that's left, that is either equivalent of level 2 or level 4, or actually, no, I should say level 0 or 2, because we did the AND 3. And flip the bit, so it's, I think, 0 if it's intermission 1, or 1 if it's intermission 2. And store that in location E0. And this is actually used by the cutscene a few times to figure out, am I playing cutscene 1, or I call it cutscene, intermission 1 or intermission 2. Okay, and then we'll skip ahead. This turns off the sprites. This initializes the music. And all the music routine is up at A000 hex. And then we jump to 1000, which actually plays either cutscene. As I said, it diverges, it starts on the same cutscene, but it checks this location E0 a few times to decide what sprites to show, and the conclusion of each intermission is custom as well. The cutscene is kind of, as I showed, a big busy loop scripting event. Eventually it returns. As soon as all the moving animation's done, it actually returns back to here and starts doing a busy loop, checking for location FF. And that is waiting for the music to conclude. So when the level ends and either like the monster eats Freddy or the tank appears, the animation is done in the sense that there will be no more moving. But it's going to wait here until the song stops. And their little music engine actually will put a 0 in location FF when the song is done. So it's a little busy loop. And then F2 for F just reinitializes the VIC registers. And the cutscene is over and goes back to the game. Okay, so we can use all that information to actually do our little level skip. I think we've got a good enough idea of most of it. Yeah, I mean, this game, though, this is an early, simple game, and it's amazing how it's its own world of code. I'm amazed whenever I dig deep into one of these games. I've spent days looking at this game, and I want to impress on you that I'm only understanding maybe 10% of the game. There's so much, like, I don't fully understand the music routines, so I spent some time in them fixing them. I sort of understand how the cutscenes work. The actual gameplay, besides picking up the gold coins and stuff, I don't understand how the ladders work. I don't know the monster AI. I don't really know the input output. So we're spending all this time just understanding a small fraction of this game. That blows me away. And just in case you hadn't thought of that yourself, I just want to kind of stress that. I think we understand this little section enough now. Now, the thing is, when you want to press the button to skip the cutscene, that code has to go somewhere. It has to be executed. Well, what code is getting executed? You can see how there's this kind of control structure. Once we jump away the animation scene, the control isn't here anymore. The control's going on, if we look back at 1000 here, here's the beginning of the cutscene. And as I said, it checks here for that E0 is a cutscene 1 or 2. And it does all the sprite initialization. It does all this stuff. Where do you inject a check for that joystick button? Well, I think that's what we found at the very beginning, that delay loop. I'm going to look at that again. 12F6. This is the most consistently run bit of code here. So this is where we're going to put it. Actually, this reminds me, I'm going to quit out. I had some trouble with the game crashing, so I'm going to go back to the title screen. And now we're going to apply our patch. I just didn't want to do it while that code was active because that can just crash everything. Okay, so just again, we'll look. Here's this delay routine. So what I'm going to do is rewrite this. I found some free memory way up at FA00. So we're going to start assembling there, FA00. And what we're going to do is just basically imitate the program above, but I'm going to add some things. So the first thing I'm going to do here is where it's load a C8, like I was saying, that precisely delays 1000 cycles. We're going to be using a few more cycles to read the joystick. So it's somewhere between C6 and C7. We don't have a fine enough resolution to exactly match it. I don't think it matters that much. We're just going to count 5 less cycles here to partly make up for what we'll be adding. Okay, and then we're just going to copy the code above, subtract 1, branch if not equal. We have to branch to FA02, just the line above. So we're just changing that. So we've burned roughly 1000 cycles, or 995 or so. Now we're going to load DC100. Well, that's the joystick port. And we're going to AND it with 10 hex. And that 1 right there, that's bit 4, is the actual joystick fire button. So we're going to mask that out because we don't care if the user is wiggling the joystick around. And we're going to branch if that's equal to ahead to FA11. It will be equal to 0 if the joystick button is pressed. And because normally it's 1 or high. So we're going to branch ahead to that FA11. Looks like kind of like fail. And so now we've inserted our joystick detection. We're only going to check it once every 1000 cycles. If we were checking it every time through that loop, we would be wasting way more cycles and throw the timing off really severely. So basically we're going to, it doesn't matter. 1000 cycles goes like that. There's 1,000 cycles in a second. Now we're going to continue on with above the 12FC, the decrement Y. We're just going to do that ourselves here. And we're going to branch, if not equal, back up to the top of our subroutine at FA00, because that means there has not been a joystick press. So we're going to just decrement Y again and do it all again. And then once we've done the full delay and nobody's pressed the button and the full delay Y times 1000 cycles is being used up, we're just going to return. Okay, now comes our part at FA11. This is if they did press the button. This is kind of ugly, but what we're going to do is pull A and pull A again. And what that does is because this subroutine has been JSR'd and then JSR'd again. So what that means is 2 16-bit addresses have been pushed on the stack. And we don't want to just return once because that would just mean the delay finished. But if somebody pressed the fire button, we want to not only escape from this delay routine, we want to escape from the whole, I say escape, but return from the whole animation routine at 1000 hex. We want to go back to that previous control loop. So this is ugly. I'm not proud of this, but we're going to pull the previous return address off the stack. So when we do a return now, it's going to go all the way back out of the cutscene loop. And now we have to do one other thing. I figured this out. We have to load A with 0 Otherwise, we'll return. And do you remember that little loop checking for FF to indicate that the music is over? We have to do that ourselves manually here. Store A and FF. And that's going to signal that the music is done. Kind of, we're going to lie. Otherwise, the animation would stop, but it would still sit there and wait for that whole 15-second song to end. Don't bring me down that unlicensed ELO tune. Pretty awesome. Okay, so that should do it. There's just one thing that we have left to do. Various routines call that 12F6 up here, the original delay routine. So what we want to do is instead, whenever that delay routine is called, we want to just jump to our own new patch at FA00. And just to clean up after ourselves, I'm going to put one NOP after because there were 4 bytes there previously and we just overwrote 3 of them. I don't know if that's necessary, but anyway, a little bit cleaner. Okay, so now after all that, we're going to exit. I'm going to resume. Okay. Let's see, can we jump through cutscenes now? Let's grab that. All right, there's our cheat still active. Here we go, cutscene. Seems to be working. Okay, here we go. Woohoo! Level 3. There, basically spawned on top of one of those gold pots. Okay. So now I think we got everything we need. We got the infinite lives. We've got the cheat for just 1 pot of gold. And now we've got intermission skip. Let's go through this game. And I don't know if I have to warn you that this is going to be, you're finally going to see the end of this game. Some of you have been playing this for 40 years. I don't think anybody's legitimately ever beat this game. All 16 levels. It gets so difficult around level 13, 14. Crazy difficult. There we go, level 8. Okay, level 9. Look at those. You ever seen those before? Level 10, there's a Canada flag. And like snakes or something. Okay, once again with the interlude. Level 11, some sort of aliens. And what is that, a little walkie-talkie for the pickup there? Level 12, these weird guys. Oh, there's a music clef. Okay, we're getting close. Level 13, it's a Christmas tree. And some absolutely bizarre, like, what are those, cheerleaders? Level 14, there's a Commodore symbol. And more weird kind of aliens or something like that. Okay, level 15, bizarre lollipop guys or something. Ah! Oh, we never got to see the prize on that level. I got forced to solve the level. Look! Atari symbols and a diamond ring or something. Okay, here's Freddy's Revenge. I'm going to let it play. And then we're going to see what happens after famous level 16. Here we go. And here is the bizarre kind of end sequence. So the scroll text doesn't seem to be saying anything special, but there's a blue Freddy at the top of the screen. Looks kind of like zombie. Is that zombie Freddy? He's blue. He looks kind of like Michael Jackson from Thriller. Wasn't he kind of blue? And here's what makes me think that even more. Watch when Freddy reaches the end. There. Now he's moonwalking. So there's all kinds of rumors about this. Like the Wikipedia page said, this is a buggy thing. There's no ladders, so you can't finish the level. To me, this seems like it was on purpose. Because, like, what are the odds that Freddy would show up and do a blue zombie mutant moonwalk across the screen by accident? I don't know. So I actually reached out to programmer Chris Hadlett again on X Twitter, and he confirmed that it is a bug, that the level should have been ended with 15. It was going to be a level wrap, but then go faster, but we didn't test enough. Yeah, I guess basically the game should go back to level 1, but it would be even more difficult, even more monsters probably, even faster. So the only thing is that this is pretty amazing that the game would behave in this way. Like I said, so I don't know if they realized it wasn't working the way they wanted, but maybe they hastily... I'm not at all doubting, Chris, that it's a bug, and a bug caused this, but maybe they refined it a little, or this is a little bit of a compromise, or they came up with a quick hack to make it at least do this as like a game over, an end sequence. I don't know. So I don't know how we're going to fix this, because I don't know how it really should behave, and frankly, this has gone on long enough. I've had my fun. Maybe in the future, we'll find out from Chris Hadlett exactly how he wanted this to work, and maybe we can figure that out. I should point out that there is a Frantic Freddie 2 that was made like unofficially. I think it was programmed from scratch, and it's very much like Frantic Freddie, but it does some things maybe better. I don't know. I just want to make you aware of that. I haven't even really tried that myself. Okay, but we're not quite done, because normally this would be the end, and you try grabbing the pots of gold, and you could only get, like, in this case, 3 of them. They're randomly placed, by the way, but you get, like, 1, 2, or 3 of them maybe, and then that would be it. You couldn't finish the level. Okay, but we still have our cheat active, so we'll have to pick up 1 pot of gold. What's going to happen? Let's try it. Here we go. Watch Freddie up there. Okay, so here we are on level 18. That short little jingle played as if we had finished the level. Well, I think what's happening is it's playing, now that we're playing these out of bounds levels, 16 was supposed to be the end, 17 played the title music, 18 played the little level done jingle. And if we go further, we're probably going to start hitting, where's some text? You're doing quite well, really. Watch you don't break that joystick. Okay. So, anyway, level 18. Well, we got more pots to go. Let's go level 19 and see what happens. Okay, we got another interlude here. I'm just going to let it run for fear of messing something up. What will level 19 say? Okay, look at this. Look at the text. How did you get this far? I guess I will have to immobilize you. Congrats from Chris Hadlett, Greg Larson, Doug Scott, Fred. Okay, the music is hung. It's gone buggy, audiogenic, and CDS. Let's see if you can get any farther. Look out. How did you get this far? So it's almost like this is the game over or congratulations message, and yet it's reached only by cheating. The music's just hung on a note. If that's too annoying while I'm editing it, I'll drop the volume out, but just so you're aware, it's still going. Yeah, it's still just making that noise. So I don't know, is this purely a bug? I mean, it's aware that we're on an invalid level. Okay, I'm going to keep, and look at Freddy's. He's like, zombie Freddy. Okay, we'll go level 20. Now the audio's really messed up, and there's Freddy going backwards. Okay, level 20 is done. I think we're going to skip this one. I think level 21, upside down Freddy. Look at the scroll text. And upside down Freddy, he's not looking too good there. Oh. Level 21. How far can we go? Level 22. Oh, Freddy's invisible. Counting up score 10, 20, 30. Weird sounds. Okay, now Freddy's invisible, but look. Oh, there. There, I was still able to collect Pod Gold. Oh, now it's so glitched out. Level 23. 20. What is going on? What's that? What are those shapes? It's like those alarms or something. Now we've got multiple scores. Okay, I'm going to try and grab the next one. Level 23 is done. Oh, there's Freddy's face at the bottom. Level 24. Ladders are all messed up. Grab, okay, level 25. Oh, another interlude. Whoa, check out the prize thing. Whatever, you know, those are bonus points when you pick that thing up. And Freddy's still invisible, but I think he's still there in the bottom left corner. In case I haven't made that clear, I've just been pushing right on the joystick to get... Oh! They're actually coming down. Maybe those are monsters. Okay, level 26. I'm coming. Paquette. Now the prize is freaking out even more. I just keep saying Paquette. That coffee mug says KH on it. I think that's Chris Hadalid right there. KH, that's his coffee mug while he was making this game. I just want to see what that does. Oh yeah, look, it's coming down. It's like those are monsters. Oops, somebody got 1,000 points. So if this is boring, this is absolutely wacky. We're in Glitch World for Frantic Freddie. Oh, look, it's going down the ladder. Down to nowhere. Where'd they go? Oh, they came around the top. I love stuff like this. Oh, he's going that way. I was kind of hoping that they might come over and find Freddy and kill him. Okay, I'll wait one more time if they come off of that ladder and go left. Come on. No. It's going to wrap around again. Okay. Okay, what's on level 27? I need to walk to the right here. There we go. Race full. Oh, that sounds terrible. Okay, I think it's totally crashed. Cool sounds. Oh, look, it's got a Canada flag there. Top left corner. Oh, Canada. Okay, well, it is bombed. See if restore still works. Oh, yeah. Can we start over again at level 1? Yep. So, game still does seem okay. Okay. Okay, so that was, to me, way more fun than going through fixing the SID, which is just changing all the D5 references to D4. I had like 100 times more fun. I hope you did too. Now, I'm not adverse to trying to fix the end of this game, as I said. I think we'd really have to know exactly how Chris wanted it to behave. I don't know. Maybe somebody else wants to take this on. It might be fun. Okay, so I hope you enjoyed that. Like I said, I did very much. And I still don't think we've touched all the little fun details there are in this game, but that's it for now. Thanks very much to my patrons for their support, and thank you for watching, and we'll talk to you next time.